We are living in an age of incredibly powerful AI, right? These models can write code, they can create amazing art, they can reason in ways that feel, well, almost like magic. But behind all that magic, there's a giant hidden problem. And it looks like a team at NVIDIA may have just cracked the code to solve it.
And it's no surprise that this breakthrough comes from NVIDIA, the company whose hardware is pretty much the engine behind this whole AI revolution. They're on a quest to make AI not just more powerful, but smarter and way more efficient.
So that leads us to the big question. We have these amazing, mind-blowing tools at our fingertips, but what is the actual price we're paying to run them? What's the real cost?
And the costs, they're huge. These giant models need a staggering amount of computational power and memory. And that translates directly into massive energy bills and makes them incredibly expensive to actually use in the real world. This is the bottleneck we have to solve.
This really brings us to the heart of what's called the AI efficiency problem. We want all the brain power of these huge models, but we need it in a package that's smaller, faster, and frankly, cheaper.
Now, a pretty common solution is a technique called quantization. It sounds technical, but here's the deal. At its core, an AI model is just billions of numbers. Quantization is all about simplifying those numbers, kind of rounding them off, to save space and speed things up.
And this is the perfect analogy. Think about it. Quantization is just like taking a beautiful, high-resolution photo and saving it as a compressed JPEG. Yeah, the file gets a lot smaller, which is great, but you always risk losing those crisp, fine details that made the picture so good in the first place.
And there's the catch. When you compress an AI model, that loss of detail means a drop in performance. The model literally gets worse at its job. It becomes less accurate, less capable. To put it bluntly, it gets dumber.
So researchers have been trying to fix this dumbing down problem for years. But for today's super complex AI, the old solutions are starting to fail. And I mean fail spectacularly.
The traditional fix is something called quantization-aware training, or QAT for short. The idea is you take your new, shrunken, not-so-smart model and you basically try to retrain it, hoping it'll relearn everything it lost during the compression.
But in the real world, QAT can be a total mess. It's complicated, it's often unstable, and a lot of the time you need the original training data, which you might not even have access to. And for today's most advanced AI models, the ones trained in all these complex stages, QAT just doesn't work. It often fails completely.
And this just lays it out perfectly. On the left, you've got the old way, QAT. It's complex, it's risky, it's prone to just breaking. On the right, you have NVIDIA's new solution, a much better bridge called quantization-aware distillation, or QAD. It's designed to be simple, stable, and to actually preserve the model's intelligence.
And this is where the aha moment happens. Instead of trying to force a dumbed-down model to relearn everything from scratch, NVIDIA's approach gives the small model a perfect teacher to learn from.
This whole idea is called knowledge distillation, and it's so elegant. You take the original, full-sized, super smart AI and you call it the teacher. Then you take your new, shrunken model, and that's your student. The goal? Have the student learn directly from the master.
And here is the magic. The student isn't just memorizing the right answers, like an old-school training. No, it's learning to mimic the teacher's entire way of thinking, the nuance, the probabilities, the why behind every single decision. It's a much deeper way to learn.
This slide shows the core difference perfectly. On the left, you see QAT learning from these simple black and white labels. But on the right, the QAD student is learning from the rich, full-precision teacher. It's getting this detailed guidance that shows it not just what to think, but how to think.
All right, so the theory sounds fantastic, doesn't it? But does it actually work in practice? Well, NVIDIA put QAD to the test, and the results are pretty fascinating.
So this first test measures how faithful the student is to the original teacher. They use a metric called KL divergence. Just think of it as an error score. 0 means it's a perfect copy. The old method, QAT, has a score of 0.311, so pretty different. But look at QAD, a score of just 0.004. It creates a student that's a nearly identical twin of the original smart model.
And that faithfulness pays off big time in performance. This chart shows a model trained with a method called supervised fine-tuning. You can see the original model's accuracy on the left. That's our baseline. The old fix, QAT, actually makes it worse, but the new fix, QAD, boom. It recovers nearly all of the original performance.
Okay, but this is where it gets really dramatic. This is a much more modern model, trained with a complex method called reinforcement learning. And here, QAT is a total disaster. Look at that massive drop. It's a catastrophic failure. But then look at QAD. It brings the performance right back to where it started. This is the key breakthrough, right here.
And get this, the method is so powerful, they found that even if you train the student model using only programming code data, it still learns the teacher's math skills. The teacher's thought process is so rich that the knowledge just transfers across different subjects. It's a truly remarkable result.
So let's pull all of this together. What does a breakthrough like this actually mean for the future of AI and for all of us?
Well, QAD effectively solves those big problems we started with. It reliably makes small models smart again. It works on the really complex AIs of today, and it's incredibly robust. This is the key that unlocks powerful AI, making it more affordable and accessible for everyone.
And this isn't just about huge data centers anymore. This technology unlocks the ability to run incredibly sophisticated AI right on our devices, on our phones, in our cars, you name it. And it does it all while using less energy and shrinking the environmental footprint of AI.
This innovation is a massive step forward. By making top-tier AI performance cheaper, smaller, and more efficient, NVIDIA is basically opened up a whole new world of possibilities. And that leaves us with one really exciting question to think about. What are we going to build with it?